Hello everyone, myself Aniket Jain, and today we are going to discuss another question of computer-oriented numerical mathematics. So the question is, write algorithm for evaluating the polynomial px using brute force technique iterative approach. So the algorithm is step 1, read xn, then step 2, using for loop I equals to 0 to n by 1 do read ai, and for step 3, assigning p as ai. Then step 4 is using again for loop for I equals to n to 1 by minus 1 do. Now assigning p as ai minus 1 plus xp. And for then step 5 is print p. Step 6 is stop. Thank you. Hello everyone. Myself Aniket Jain, and today we are going to discuss another question of computer oriented numerical mathematics. So the question is, write a program for finding the roots of a given quadratic equation. Consider all possible input conditions and all scenarios. Now first we are importing math library and creating a function find roots and taking three inputs in it, a, b and c. Now we are using if statement. Now if a is equals to 0, print invalid and return -1. Now we are doing d equals to p into b minus 4 into a into c, and a variable square root value equals to math dot surt absolute value of d. Now if d is greater than 0, print roots are real and different. Then print minus b plus square root value divided by 2 into a, and print minus b minus square root value divided by 2 into a. And if d is equals to 0, print roots are real and same. Then print minus b divided by 2 into a. Now if else statement is following and the condition is d is less than 0, print roots are complex. Then print minus b divided by 2 into a plus I square root value divided by 2 into a. Then print minus b divided by 2 into a minus I square root value divided by 2 into a. Now giving values to a, b and c and calling function find roots. Thank you. Hello everyone. Today we are going to discuss another question of computer oriented numerical mathematics. So the question is, write an algorithm or program or flowchart caught finding cube root of any given positive number without using any built-in function. So creating a function diff and taking parameters n and mid. Now if n is greater than mid into mid into mid, return n minus mid into mid into mid, as written mid into mid minus n. Now creating another function cubic root and taking a parameter n. Set start and for binary search. Start is equals to 0 and equals to n. Now set precision, that is e is equals to 0.00001. Now making a while loop. In that condition is true, mid is equals to start plus n divided by 2. Error is equals to diff function and mid. If error is less than e, then mid is our answer, so return mid. If mid is greater than n, set n equals to mid. If mid is less than n, set start equals to mid. Else start equals to mid. Driver code n is equals to 3. Then print cube root of n. That is calling this function. Thank you. Hello everyone. Today we are going to discuss another question of computer oriented numerical mathematics. So the question is write algorithm or program or flowchart for finding roots of equation x square minus x minus 1 equals to 0 using fixed point iteration method. So the function is x square minus x minus 1 equals to 0. Now starting the flowchart. First of all, assigning a equals to xl and c equals to xb. Now doing bisector interval, that is b equals to a plus c upon 2. Now checking sign, that is fa into fb is less than 0 or not. If this condition is true, then c is equals to b, updating the iterable. If this condition is false, then assigning a equals to b. Now checking a while loop where modulus of a minus c is less than a, we are checking convergence. If this condition is true, we are giving output root equals to b. If the condition is false, then the step will go back to bisect interval and corresponding if statements will check again till that check convergence condition is true. Thank you. Hello everyone. Today we are going to discuss another question of computer oriented numerical mathematics. So the question is write algorithm for Gauss-Jordan Iterative Method, then compare its performance with Gauss Elimination Method. So the algorithm is read number of unknowns n, read augmented matrix A of n by n plus 1 size, transform augmented matrix A to diagonal matrix by row operations, obtain solution by making all diagonal elements to 1, then display result. Now, the difference between Gauss elimination method and Gauss-Jordan method. The- So the first difference is in Gauss elimination method. In this method, the unknowns are eliminated successfully and the system is reduced to an upper triangular system from which the unknowns are found by back substitution. And Gauss-Jordan method. In this method, elimination of unknowns is performed by all equations not only from equation 2 follow. Thus, the system ultimately reduces to a diagonal matrix form, that is, each equation involves only one unknown. Second point is finding the solution of an simultaneous linear equation. The number of multiplications and divisions are of the order n 3 by 3. For example, if n is equals to 5, the number of multiplications and division ISI elimination is approximately 42. In Gauss-Jordan module, finding the solution of an simultaneous linear equation, the number of multiplications and division are of the order n 3 by 2. For example, if n equals to 5, the number of multiplication and division are approximately 62. The third point is it does not seem to be easier but requires about 50% fewer operation than Gauss-Jordan method. In Gauss-Jordan method, it seems to be easier but require about 50% more operation from Gauss elimination method. The fourth point is for larger systems, Gauss elimination method is preferred. In Gauss-Jordan method, for large systems, Gauss-Jordan method is preferred to Gauss elimination method. Thank you. Hello everyone. Today we are going to discuss another problem of computer-oriented numerical mathematics. So the question is, iterative method are superior to the elimination method. Write 4 disadvantages of Gauss elimination method and write 3 advantages of Gauss Seidel method. So first, 4 disadvantages of Gauss elimination method. The first disadvantage is division by 0 during row normalization. Second disadvantage of Gauss elimination method is round of error. More significant figures gives less error, important when dealing with 100 or more equations. Third disadvantage is if the matrix is singular or nearly singular, the Gauss elimination technique fails. The fourth disadvantage is for complex equation systems, the computing cost can be high. Now, three advantages of Gauss Seidel method. So, the first advantage of Gauss Seidel method is easy to program. The Gauss Seidel method is relatively simple to implement in code, making it a popular choice for solving system of linear equation. Second advantage is fast iteration. Each iteration of the Gauss Seidel method is relatively fast, making it a good choice for large system of equation. Third advantage is less memory space. The Gauss Seidel method requires less memory space than the Gauss elimination method, making it a good choice for system with limited memory. Thank you.